G'day and welcome back. On my last video where there was a problem with the winch trying to lift 2 buckets of rock, which is estimated about 80 kilos. Now I will measure it. I don't have 2 buckets of rock just yet. When I get them I will weigh them out of interest. So we estimated about 40 kilos each, so 80 kilos. The thing's rated for if you can read that, 125 kilos with a single cable, so it should have worked. One of the comments on the video was from that one UFO, and they suggested there could be a voltage drop problem, and they're right, it could be. The cable from here to the power point is, I reckon, about 30 meters, and it's a standard sort of extension lead size cable. I haven't measured the size of the cable because I don't want to cut it up, but it's not a particularly thick cable like an industrial sort of cable that I probably should buy. There's actually 2 of them joined together, which you shouldn't do, so don't do that. Don't do as I do. But that's what I've done, and it works fine except for now. So what I'm going to do is measure the voltage drop when the winch is under load. Now at the moment all I've got on there is the jackhammer, so it's not a particularly big load, but it'll do for the first test. Then I'll go down there, dig up 2 buckets of rock, and then lift the 2 buckets up again, and so lift it till it fails, and see what the voltage drop is then. So it's generally fluctuating around 238-ish volts when there's no load. Interestingly, it does fluctuate quite a bit, I noticed, 236, 235-ish. I won't go into much of the details, but when there's no load on an extension lead, so there's nothing, it's not doing anything, there's no lights or motors or anything, then the voltage at the end of the extension lead will be the same as the socket. I won't go too much into why that's the case, it just is. So now I'm going to lift up the jackhammer, see what happens to the voltage. So it goes down to about 233. Oops. Go back down. Yeah, so it doesn't go down as much when the winch is going down. I suppose it makes sense. It's doing less work and drawing less current. So voltage drop is the thing. So I'll go down and jackhammer some rock out, lift up the buckets. And in general, if you don't know what you're doing with electricity, just don't play with it, especially 240 volts. I'll just add that if you're starting out or you haven't got a multimeter, then I'd almost always recommend that you don't get a fluke, because they're really good, but they're really expensive. Get something like this. It's a Uni-T UT892, this one. They've got some other models too. They're really good, and I think this was 60 bucks. From memory, I think I bought this 25 years ago, and I think it was $200 then. And I think they're, I don't know, I'm only guessing, $400 or $500 now. So really good in terms of accuracy and durability and everything like that. But less features and a whole lot more expensive than something like this. Yeah, the voltage has gone up now to 242, or close to. Anyway, I've got the 2 buckets loaded up the same as last time, one after the other. So the first pull will be just lifting up 1 bucket like this. They went down to 237. Now just about to take up the slack on the second bucket. So next time I turn on, I'll go to lifting up 2 buckets. Which it was just, you can hear it failing. So I won't push it anymore. It's a bit of a bugger because it's almost come up all the way. So I'll let it go down, I'll pull up 1 bucket at a time. but this exercise is mainly to look at the voltage drop. Let's try and go up a bit more. So 242 to 237. What's that? 5 volts. It's not too much. Not too much. I thought it'd be more than that. That'd be right, they both fell over. Anyway, I'll get down there, top the buckets back up and pull them up one at a time. Now there's another comment from Kryptonite Rick about the duty cycle of the winch, and that's a good point. The duty cycle is sort of the run time versus the off time. So run it for say 20 seconds and give it a minute's rest or something like that. I was going to measure the temperature of it because that's a bit of an indication of duty cycle, see how hot it gets, how quickly. But I left my temperature probe underneath someone's house. I was under there running some cables, and while I was under there I was doing the right thing and checking for termites, or potentially termites, and like an idiot I left my temperature probe under there. So I'll go and get that during the week, and we'll measure the temperature of the winch one day. 24 kilos. So 27, 24 and 27. According to the scales, about 51 kilos for the 2 buckets full of rock, and the lift was right on the verge of failing. Well, it did when it got to the top. So that's interesting. And with a single pull set up like this, it's rated to 125 kilos. Could be voltage drop. It wasn't that much. It was about 5 volts. So wouldn't have thought that would do it. And it could be a duty cycle thing, but to touch the outside of the motor, like when I was touching it here, it was barely warm to the touch. And that doesn't mean it wasn't really hot inside, but it's generally they're designed so the heat goes to the outside. But I don't know, it's a watch this space sort of thing. Let me know if you've got any ideas. I will measure the temperature one day. I'll get my thermometer back, my laser pointer thing. Okay, this is the drawing that I did to sort of show how it's set up. The power socket on the left, the blue box, which we measured as 242 volts right before the hoist was turned on. Then the two 15 metre power cables, which I found out it's written on the side of the cable that they're 1mm squared conductors. That's interesting information. Hoist in the top right corner, the grey box, and the meter, little yellow box, which measured 237 volts when the hoist was working, which means there's a 5 volt drop when the hoist is working compared to when there's no load at all. And that's effectively what we did. That's it for now. But as always, keep on digging.